You might see sine x cos x and think, I need to create a sine 2x there, right? Because I know that often after we've done the compound angle identities and the double angle identities, that's almost all that people tend to kind of look for because it's new. But remember, guys, I told you yesterday, these exercises, it's exercise 5.2, these exercises were done before the identities were introduced in the textbook. So these were supposed to be grade 11 level equations that they were just kind of revising. Now, guys, when I see sine x cos x, right, I immediately think of a trinomial that has a sine squared x, a sine x cos x as the middle term, and a cos squared x as the last term. So one of these, like an x squared plus 3xy minus 6y squared. I'm just making that up. That actually can't be factorized. But that type of trinomial, right? Where in your brackets you're going to have an x and a y and then an x and a y. If I just had a sine there, so not the cos x, if it was 2 minus sine x minus 3 cos squared x, then I would change this cos squared x into a 1 minus sine squared x, right? If I didn't have that cos there. If I had a sine x and I had a cos squared x, I would change the cos squared x to 1 minus sine squared x so that I have a sine trinomial, right? But because I have a sine x cos x, I am going to have to introduce a sine squared x as well so that I have this type of trinomial. So a trinomial with the one variable squared, the other variable squared, and then the two variables, both of them in that middle term. Now, guys, the trick to this one is that you need to recognize that 2 is the same as 2 times 1. Right? And 1 can be replaced by sine squared x plus cos squared x. Right? We learned in, when was it, grade 11, that sine squared plus cos squared is equal to 1. So because I'm recognizing that I need a sine squared, and obviously, guys, if I change this cos squared x into 1 minus sine squared x, I don't have a cos squared anymore, right? So then I have the same problem. So we actually are not going to change this cos squared x at all. We're going to leave it as it is. But in a way of introducing sine squared, I am changing that 2 into 2 times 1, essentially. Okay. Minus sine x cos x minus 3 cos squared x equals 0. Yes, I did. It's there. Yes. All right, I'm going to do the multiplying out and the simplifying in one step. So can we visualize that? If I multiply the 2 in, I'm going to get 2 sine squared x, right? But then I'm also going to get 2 cos squared x, which I must then minus 3 cos squared x from. So what's that going to give me? 2 cos squared x minus 3 cos squared x is going to be negative 1 cos squared x, right? So I'm going to have my minus sine x cos x minus cos squared x equals 0. Right, now this is one of those trinomials where you have a sine squared and a cos squared and a sine cos in your middle term. So when I now factorize that, I'm going to have sine x cos x in my 2 brackets. Not only sine x cos x, but those are going to be the variables. Okay, can we see how we're going to factorize this? I'm just going to put a 2 sine x in the one. And if I need to get my last term to be negative cos squared x, one of them has to be cos x, and the other one has to be negative cos x, right? So I'm kind of jippoing this factorizing. I'm not really thinking in terms of factors of this so that it will give me that and that. I'm just kind of seeing which 2 brackets I need to multiply together. What must my signs be here so that I'm going to get this middle term? If I have positive 2 sine x cos x, so say I put a plus there, and I put a minus there, is that going to work? No, that's going to give me positive sine x cos x, right? I need a negative sine x cos x. So I need to put my plus there and my minus there. Is that going to work? Negative 2 sine x cos x plus sine x cos x will give me that middle term. Or guys, you can use the calculator for this, but you're going to have your wits about you. Let me quickly show you what you would have to type in, because remember in core we want to see these two brackets, right? So we are going to have to say mode 5 for equation and 3 for the quadratic. What is the coefficient of my first term? 2. Of my middle term is negative 1. And of my last term is also negative 1. So this is saying that x is 1. Right? Now we can't say x minus 1 in a bracket. Obviously, we have to say sine x minus 1 cos x. Right? So it's actually, I don't know, it's a bit more tricky actually for me to use the calculator instead of just thinking of what I must multiply. And then the other answer that I'm getting is negative 1 over 2. So if this was an x bracket, we would have to say 2x plus 1. But now we're going to say 2 sine x plus 1 cos x. Okay. Guys, this is really kind of higher level stuff. It's, yeah, the chances of you getting a question like this in finals is not great, but maybe we throw one of these at you in your mock exams. I don't know. We'll see what happens. Okay, so now we have to say that, sorry, I'll go back into black. Do we agree that from this first bracket, sine x is going to be negative a half cos x? Is that right? So I would say 2 sine x is equal to negative cos x, and then we would divide by 2. You can also say negative cos x over 2. Same thing. Because remember, if we have two brackets equal to 0, you take your first bracket, make it equal to 0, and then your second bracket as well. So I'm going to say or sine x is equal to positive cos x. Right? And now I hope that you guys remember that trick where you are going to turn this into a tan. Do we remember? So I'm going to divide by cos x. What is sine x over cos x? Tan x equal to negative a half. And on the other side, if I divide by cos x, what's left? On the right, 1. Okay, shift tan of a half is 26,56, or 57 actually. And it's negative, so in which quadrant am I going to work for? Negative for tan. Quadrant 2, so I'm going to say x is equal to 180 minus this, which is 153,43 plus 180n. And you guys would have written n element of z already in previous questions, but if you hadn't, this was the first equation that they gave you, which would be quite mean. But if that was the case, then you would have to write that there. I'm just going to move this a little bit. We don't need to do the second, well, the fourth quadrant, the second general solution, because it's tan, right? So quadrant 2 plus 180 will just give you quadrant 4 anyway. For this one, the reference angle is going to be 45. And it's positive, so I'm just going to work in quadrant 1. So x is 45 plus 180n. They asked for, oh, they just said solve. So they didn't give you an interval there for specific solutions that you had to give.